We go to the last part of the chapter, the techniques to do thawing and tempering. Okay, we can do thawing and tempering by using air. We can do by using water. We can do by using steam condensation under vacuum. Steam, what is steam? Steam is like actually a water vapor at high temperature. Okay. Steam condensation means now you are from steam, you convert it into the what? Liquid water, and this is called condensation. This process, this conversion, release heat or absorb heat? Release heat. Release heat means supply this heat into the frozen meat, frozen food to thaw. Okay, so this method you use the heat which relieve from condensation of steam to thaw the product. What kind of heat do we call this? There are two kinds of heat, but this kind of heat is called what? Latent heat. What is the other word? Sensible heat. For this method, you use sensible heat of the air. You use sensible heat of the water. This method, you use latent heat. What is the difference between latent heat and sensible heat? Are both heat exchangers, but sensible heat exchange means when there is a change in temperature, you feel it. But latent heat, there is exchanged heat, but the temperature doesn't change. Example, this happen at what temperature? If 1 atmosphere, this happen at what temperature? 100 degrees C, right? The same at 100 degrees C, as long as there is still conversion from steam to liquid. It's called latent because it doesn't change in temperature. Now, but they do this not at atmospheric pressure, but they do this at what condition? Vacuum. Why not atmospheric pressure? Because if we do at atmospheric pressure, then what temperature? 100. Then what do we do? It is thawing? No, actually cooking. So we do at vacuum to lower the condensation temperature. So not to cook the food, but just to thaw the food. Okay, this method is good. Why? Because when steam is converted to liquid and air, which one have a better contact with food? Water or air? Water. Better contact, better heat exchange. And also you use a latent heat. Latent heat is a lot of heat. What is the latent heat? What is the, how do you call that? Evaporation latent heat of water. Somehow like 2,225 maybe kilojoule per kilogram. What is the sensible heat of water for 1 kilogram? Sensible heat of water is like this. Mass of water multiplied by the specific of water multiplied by the change in temperature. If you change 1 degree C, then it's okay. Then what is the Cp? 18 kilojoule per kilogram degree. Means that if you consider 1 kilogram, then means that when you reduce 1 degree C of 1 kilogram of water, you can only supply to food 4 kilojoule. But here, when you condensate 1 kilogram of steam, you give to food 2,000, more than 2,000 kilojoule. A lot of energy, right? Means when you condensate 1 kilogram of vapor, you give a lot of heat to the frozen product. When you lower 1 degree C of 1 kilogram of liquid water, you only give 4 kilojoule. So the latent heat is normally a lot more compared to sensible heat. That's why with this technology techniques, you can do fast thawing. Good. And nowadays, we apply more and more microwave thawing. Very big advantage of this technique is that it can thaw the food very fast, much faster. Air thawing. We use air set at 2 to 18 degrees C. You need a room, a large room. You put your frozen meat, food inside. You wait there for quite a long time, 8 to 60 hours, depending on the size of the food. And then the heat from the air will move to the food, and then the heat from the surface will transfer inside by conduction. Okay, from the surface inside by conduction, when the heat transfer in the air by convection, and then we need to humidify the air. Humidify. What does that mean? We need to increase the relative humidity of the air. The question is why? If the air is dry, has low relative humidity, you have the weight loss. You lose water because of evaporation. Okay, when we do air thawing and when we do air freezing, which one takes a longer time, do you think? Thawing or freezing take a longer time? If you look at the graph. Freezing, you have this time, and thawing, much longer. Thawing take a longer time than freezing. The question is why? Here, freezing, here is thawing. When you do freezing, water on the surface become ice first, right? When you do freezing, you remove the heat from food, right? When the outside become ice, this is thermoconductivity. Thermoconductivity. How fast the heat is transferred. Độ dẫn nhiệt. Ice has the thermoconductivity of ice is 4 times of that of water. You see, one error, four arrow, one arrow. When this become ice, the heat transfer is 4 times faster. When more ice is formed, the heat is removed faster and faster. But when you do thawing, what happens? The ice from outside become water. You need to transfer heat from outside in. When ice become more water, the heat transfer becomes slower and slower. And because of that, thawing take a long time. And this is one of the reasons why there is more microbial growth during thawing than during freezing. Okay, the second technique of thawing is using water. For this method, we have short thawing time, 1 to 3 hours. Why? Why is much shorter compared to air? You have a better contact between water and food than between air and food. You have a better heat transfer coefficient, better heat transfer coefficient between water and food than between air and food. So the thawing time is shorter. You go into a room of 4 degrees C, you can stand there maybe 30 minutes, you try yourself, maybe it's still okay. But if you jump yourself into a pool of water of 4 degrees C, after 2 minutes, you cannot bear it anymore, even though it's the same temperature. Because the heat transfer between water and you is much better than between air. So you see, there are many chairs in this room. For example, if this room is conditioned at 18 degrees C for overnight, and you see the many chair here, the chair has the wooden part and the chair has the metal part. When you open the room, you touch your hand to the wooden, you touch your hand to the metal. Which part do you feel cooler? Metal or wood? The metal. Is that because the temperature of the metal is lower? No. Because this chair is in the room for a long time, the temperature is the same, 18. But because the heat transfer between metal and your skin is better than between the wood and your skin. Okay. And so you lose heat faster, you feel cooler, you feel colder. The frozen product is submerged in a tank of water at a temperature above the melting point of the food. This is some instrument. For example, the frozen food is transported here into water, and there's a screw that rotate and move the frozen food from this side to the other side. And then the speed of the rotation can be adjusted also depending on the length of this instrument. Then how long will it take for the food to be underwater and get thawed the other side. Okay, water must be changed frequently. Why? To maintain high temperature and to minimize microbial growth, not to accumulate the contamination. If you don't change water, the temperature is going down, and then you cannot thaw efficiently, and also a lot of microbial grow, a lot of microorganisms inside, accumulated. So you replace water a lot, means that expensive or cheap methods, expensive. Water cost you money, but also you need to treat this. This is called wastewater. Okay, when you chart it out from the processing is wastewater, and you have to treat. It's also expensive.